During the test, we found that after shooting, the basketball returned to the starting position again, and the basketball could not move. This does not conform to the design, indicating that our basketball state management has been modified later. We need to re-examine it. First, change the initial state of the basketball to idle. You can touch only in the idle state. Find the logic of touch. First, look at the joystick touch script joystick controller. Tracing the code, we found that we need to judge the state of the basketball in the method of starting the joystick touch. Could it be that we add a reference to the basketball node in the joystick script? If we do this, it will inevitably become that you have me, and I have you, and we hold each other's references. Subsequent code maintenance and expansion will be quite troublesome. This approach is obviously not standardized and unreasonable. What should we do in this situation? In fact, a good software system sold consider the system architecture from beginning. The reason why wedded note philosophy of system design to explain to you stat wopi Brian will understand sold do see then subscription and publishing. If you don't know, the coupling between components is too high, wikis note can do civito subsequent expansion and maintenance. When you Torah construct the system. Before reconstructing, we need to understand the principles of event subscription and publishing. For everyone to understand better, let's take a look at a picture. In track and field competitions, when the starting gun in the referee's hand sounds, the athletes on the field start running immediately, the timer starts counting immediately, the follow-up camera starts instantly, and the audience starts cheering. Here, we can regard the signal gun as an event. The referee is the publisher of this event. The athlete, timer, follow-up camera, and audience are subscribers or listeners of this event. Their respective responses to this event can be considered as callback methods. So, in this case, we can get this chart. When the sprint crosses the finish line, the high-speed camera will capture the instantaneous picture, and the timer will record the athlete's score. Here, crossing the finish line can be considered an event. The publisher of this event can be considered as the athlete. The subscriber of this event can be considered as having a timer and a camera. So, we get this chart. Assuming that the camera fails at the start, you need to cancel the subscription. First, you need to find the signal gun event, and then find the corresponding camera in the subscriber on the right who subscribed to the signal gun event. Here, the event publisher only publishes the event, and the event subscriber will automatically call its own callback function to process it when it hears the corresponding event. Let's look at the data in this table. The two middle columns belong to the event subscribers and their corresponding callback functions. The first column on the left belongs to the event name. Each event corresponds to multiple lists. It is actually a map nested list structure. Let's implement an event management class based on the above analysis. It is recommended that you back up the project first to facilitate recovery in case of operational errors, and second to facilitate comparison before and after the transformation. First, we create a subfolder in the scripts folder and name it event. Create a TypeScript file in this folder and name it Event Manager. Double-click to open. Delete the unnecessary parts. Then, declare a callback function type at the top. According to our example above, we need to declare an event map to record events and their corresponding listening relationships. After that, we add an event subscription method. The event subscription method contains parameters, event name, callback function, context object. In the event subscription method, first determine whether there is already such an event. If not, add an event first, and set the corresponding listener to an empty array. Then, get the corresponding listener relationship through the event name. Then call the array's sum method to determine whether there is a corresponding subscription. If not, add the current subscription. Similarly, you also need to add an unsubscribe method. Similar to the subscription method, 3 parameters are also required. In the unsubscribe method, first determine whether there is an event to be unsubscribed. If it exists, further obtain the corresponding event subscription list. Then compare the callback function and context one by one. If found, remove this subscription relationship from the array. Okay, here comes the key point. Some students must have thought about how the event is executed. When subscribing and unsubscribing events, only the data in the map changes, and the callback function is not actually called. The callback function is called when the event is published. Now let's look at the event publishing method. Event publishing only requires providing the event name and the necessary data required for the corresponding event, such as the signal gun event, and 3 shots belong to the data corresponding to this event. Then, in the event publishing method, get the subscription list corresponding to the event according to the event name. If the subscription list of this event is not empty, traverse the subscription list. If there is a context object, pass the context object and event data to the corresponding callback function. If there is no context object, just pass the data to the callback function directly. One thing to note is that event subscription and publishing require a singleton to manage. So, let's create a new TypeScript script and name it GlobalVent. Double-click to open. Delete unnecessary code. Change it to inherit from Event Manager. Declare a private static variable instance. Add a public static method for external access to the instance of this class. If the instance of this class is null, assign it to instance after instantiation. Finally, return to instance. Okay, now back to the problem we faced at the beginning of this lesson. We don't want the basketball and joystick nodes to hold references to each other. This makes the system complicated and difficult to maintain. Now, we use event subscription and publishing to decouple the original system. Double-click the basketball controller script to open it. Comment out the joystick configuration. Then you will find that the code has an error. Click the red dot on the scroll bar on the right side of the editor to quickly locate the error. It turns out that it is the logic of controlling the movement of the basketball. Let's comment out the error code first. How to modify. Here, movement can be regarded as an event. The joystick publishes movement events. The basketball subscribes to movement events. First, we create a new enumeration class named GlobalVentType to record global events. Double-click to open. Delete unnecessary code and change it to enum. First add 2 events, one for basketball movement and one for shooting. Then in the joystick control script, find the business logic of joystick touch. Add event publishing code at the end of the touch start and touch release processing methods. When publishing an event, you need to pass in the direction of movement represented by the joystick, because the event subscriber needs this direction vector when calling the callback method. Then, as an event subscriber, the basketball needs to add relevant subscription and unsubscription logic. Go back to basketball controller. Find the relevant logic just commented. In other words, we need to add the processing logic for basketball movement. Uncomment the whole process method just now, and change this method to move process. Then add the event subscription logic in the onStart method. Add the unsubscription logic in the onDestroy method. Another thing to note is that we only allow the basketball to move when it is in the hold state. Therefore, we also need to judge the state of the basketball. We change the initial state of the basketball to hold. Save. Run and test. It is found that the decoupling is successful, and the event subscription and publishing are running normally.